All right. Good morning, everybody. And thank you for joining our webinar. Before we get started, I just want to bring this up one more time. If we can make sure that everybody is on mute while we are doing the presentation, we will save the questions until the end. The way we're going to do questions today is if you guys can use the chat function in this app. Type your questions as they come up in the presentation, and Rhys and myself will go ahead and answer them at the end. And then we'll also open it up if anybody wants to give us any questions verbally. All right, we'll start the meeting with some introductions. My name is Branko Rogovic. I'm the Western Regional Sales Manager for ATA Tools. Accompanying me in this presentation is going to be Rhys Edwards. He is our Central Regional Sales Manager, which also has a great deal of experience with air tools and has been with the company for some time now. And today's discussion, we're going to be covering how our air tools or all air tools work, some ideal setup, maintenance, use of air tools, along with some troubleshooting and getting the most tool life and performance out of each tool while keeping the cost down. Before we get started with air tools, I just want to take a quick second to go over what ATA does and what we're known for. I'm sure most of you guys already know, but ATA is known for their carbide burrs. We are the largest burr manufacturer in the world with over 1,000 different types of carbide products and have developed over 43,000 different SKUs in the past. We are a manufacturer of air tools with a range of 150 air tools, all coming out of Ireland, with a heavy focus on safety. And then we are also a supplier of abrasives with over 1,300 abrasives specializing in flap discs, flap wheels, flexi discs, and quick change discs. We are ISO certified organization, and we have international sales teams in the US, UK, Europe, and Asia. Throughout the years, we've grown organically and through acquisition. You guys might know some of these names and might not, but to go over them real quick, ATA is essentially an umbrella company with a bunch of organizations that we acquired throughout the years. SGS Pro is our main burr line here for the US. Morris Flex and ProCut are our burr lines that we sell in Europe. Garrison is abrasives and burrs as well, and then most recently Carnesh cutting tools out of Germany that we've acquired last year. Right now we'll start with the introduction to air tools, and I'm going to hand it off to Rhys at this point.
Thanks, Branko. So today we're going to go over just a brief introduction of what air tools we make and how our air tools are going to work. There's a couple different types of pneumatic tooling. First, we'll stick with ours. We do pencil grinders, die grinders, angle grinders, sanders, and belt sanders. We tend to stick to these as you can see from all the different brands we have, is we make the consumables that go on the ends of these tools. Pencil grinders, these are going to tend to hold 1/4 inch or smaller consumables. They also don't require a safety lever. They're usually going to be a roll throttle, but there's also push-pull type throttles. Die grinders are going to be for heavier material removal. Typically, are going to be straight grinders, and these can come in a variety of shapes and sizes: extended shanks, extended spindles. Then you have angle grinders. What the difference is between these and sanders is angle grinders are required to come with a guard. This is typically for very heavy material removal, and as they require to come with a guard, if something would happen, the safety mechanism. Sanders, again, they can come in different shapes and sizes. We show our most common one, which is the RA20, it's 20,000 RPM, right angle sander. We also can come with belt sanders, which is an accessory basically to the regular sanders. All these are assembled in Ireland, as Branko had mentioned before. So here are the air motor basics. We use as a vane motor. There are a few other different types of motors, such as turbine and propulsion motors. But most pneumatic grinding tools you see in the market are going to be this variety. In vane motors, there are 4 basic parts of the motor. They are the bearings, vanes, the rotor, and the cylinder. And these are all held together by the bearing housings, which you can kind of see in the schematic. So as you can see from the visual that we have in this slide, this is basically how all those parts fit and work together. So you have the vanes that are in the rotor, housed in the cylinder with kind of the bearings. You're looking at a vertical view of the bearings from the top down. How this happens is, one, the air will enter the inlet, which is the 3 little dots on the visual. That's where the air expands, driving the vanes. As it pushes the vanes, the centrifugal force, it causes the rest of the vanes to move outward onto the cylinder until the air exhausts in that darker gray part, which is the exhaust port of that cylinder. And then you go to the next slide, Branko.
All right. So airline system lubrication, now that we all are kind of aware of how air tools operate for the most part, we're going to cover how to set up your shop, how to set up your workbench, and go over lubrication. So we'll start with the big picture first. This is what an ideal shop setup would look like when running air tools, right? There are 2 different systems that a shop could have. One would be an open loop and then a closed loop. The preferred system would be a closed loop system, and here's why. Open loop systems, with open loop systems, the closer you are to the air compressor, the higher the pressure, and as you go further down the airline, the pressure starts to drop. With this, it becomes very difficult to regulate pressure, and not being able to regulate pressure for the air tool can cause a lot of problems. It could cause premature wear and failure. With a closed loop system, you will be getting even air pressure throughout your air supply, which is going to be easy to regulate, and it's not going to lead to many headaches. So next, we're going to, now that we have the shop system taken care of, we're going to look at the bench area. And I understand that not all grinding takes place at a bench area, but we will cover that at a later point. On the left of the screen, you will see the correct way to set up workbench area, and on the right, obviously, is the incorrect way. So a couple of things to point out. The drop down from the main line should be coming from above. That would be the first thing. There should always be an on-off control valve right before the regulator or the FRL unit. This is because if we want to service it or replace it, it would be nice to shut off the valve at that workbench rather than shut the whole system down. Obviously, we highly recommend the FRL unit or a filter regulator, a lubricator unit, which is going to filter the air, regulate the pressure, and add lubrication to the airline. The hose length between the FRL unit and the air tool should be no more than 3 meters or 10 feet. The pressure we recommend is 90 PSI or 6.3 bar. And then for recommended lubrication oil drip rates, you can refer to our catalog. It's in the back of our catalog. And then they will also be in this presentation coming up. Looking at the right side of the image would be the incorrect way of setting this up. And even with the incorrect way, there's still something that's good about this image is that they're using a lubricator unit. Most shops that I've been to don't actually use a lubricator unit, which is going to lead to some problems down the line. So on the right image, you'll see the main line is running below the level of the tool, no on-off control valve. The hose length is much greater than 3 meters or 10 feet, which allows the lubricant to settle in the hose and actually never end up reaching the air tool. This is probably one of the most common questions that we get selling air tools is not why lubricate, it's how often to lubricate. But why lubricate air tools, and we'll go over that. there are a lot of moving parts in every air tool that has a vane motor. As Rhys mentioned, vanes are gliding on the internal diameter of that cylinder, and without lubrication, we are creating heat through friction. So with heat, obviously, you're going to start wearing the vanes down and also damaging the cylinder. So lubrication is much needed in this area. When we add lubrication or without lubrication, we have an increased wear results. So it's going to be loss of power and speed is what an operator is going to experience. You're going to have less efficient stock removal, increased vibration, and then at the end, greater repair cost. And the worst case scenario in this situation is if we let the vanes wear out until they're small enough to escape that little slot, then they get jammed in the cylinder, and then that leads to much more costly repair, which is the last point I have to make, is overall increased production cost. So talking about FRLs, filter regulator lubricator unit, and what they should consist of, there's many different products on the market today. But here's a picture of one that's ideal. It has a filtration unit, which removes moisture and harmful solids, such as metal shavings. It has a valve that can release the water that's captured by the filtration unit on the bottom. It also has a regulator, which allows you to regulate the pressure that the air tool is going to be receiving. So like I mentioned earlier, 90 PSI or 6.3 bar. And then it has a oil canister where the oil is stored. So the way the lubrication unit works is the oil gets sucked up by that little straw that you see in there, and it gets taken up by the sight glass, and a drip would come down. About 10% of each drop actually makes it to the air tool, so we got to be mindful of that. Now on the right of the screen, you'll see our recommended drip rates depending on the size of the tool. So the larger the tool, the more oil it will require. Now these are just recommendations. If you are starting to see a lot of oil coming out, you can turn that down a notch. But when you have customers or operators that are asking, how much oil should I be putting in? Is a couple of drops every 2-3 hours or every shift okay? Just to show you the amount of oil that actually the tool requires to run properly, a couple of drops a shift or every break is not going to be good enough. So for an example, for 0.4 horsepower tool, we're looking at 15 drips per minute, and about 10% of each drip actually gets to the air tool. So constant lubrication is key here. If we lubricate it before the tool is plugged in and hit the throttle and start running the tool, that pressure is going to run that lubricant right through the tool and right out of it. Some of the things to keep in mind when it comes to having the tools run optimally is also airflow restrictions. Okay, we need to make sure that we match the air hose diameter accordingly to our air tool manufacturer recommendations. So every tool is going to have a certain orifice size that needs to match your the diameter of your hose as well as your fitting. If an air hose internal diameter is too small, the tool is going to be underpowered. If the hose is too long, it's also going to be a problem. Air fittings need to match the orifice of an air fitting needs to match the diameter that's required for the tool to run optimally. So we need to be mindful of that. You might have the correct hose, everything's in place, and have a wrong fitting and the tool is underperforming. So we just need to make sure that we pay attention to that as well. And then last but not least, lack of oil or incorrect oil in the FRL unit could also be an issue. We have, depending on the tool you order from us at least, like a right angle tool, RA20, has two different oils that come with the tool. So you will have oil for the gearing in the right angle head, and then you will have the vane oil. The oil for the gearing is slightly thicker, and you do not want to run that in the vane because you can risk breaking those vanes as it runs. So we need to be mindful of the oil that we're running as well. This slide shows an example of what poor air supply looks like, or the internal parts, what they look like when the tool is exposed to poor air supply. So lack of oil being one of them. Obviously overheating, we're gonna see scarring on the internal wall of the cylinder. Water in the air and dirt in the air could also cause bearings to fail, and even rust in certain cases. And then premature vane wear all the way to the right. Obviously, that's going to be an issue. If a vane wears prematurely, it's going to escape that little slot and it's going to jam itself inside the cylinder, causing an even higher cost of repair. So as I mentioned earlier, not everybody uses a bench grinding area, right? We've seen customers or shops that work on much larger pieces and don't have the capability of having a downdraft table to grind their parts on. So this picture shows you a solution of a way to utilize the lubrication unit along with a 3-meter or 10-foot hose, even in that environment. So there are ways, and we should try our best to make the tools run, because at the end of the day, all that's going to yield to is some cost savings. And last but not least, this is for the most part with every manufacturer, no lubrication at all for an air tool is going to void the warranty. Our warranty covers non-wear items and manufacturing defects. Lack of lubrication will void that warranty. And then also, just to mention out there that our warranty our tools are covered under a 1-year warranty. Right now, I'm going to hand it off to Rhys, and he's going to go over a little bit of the maintenance.
All right. Now we're going to discuss the types of maintenance that are that you kind of perform on air tools. There are 3 types. One, it really doesn't need covered. The other 2 we'll cover in the following slides. So the first type of maintenance is going to be reactive maintenance. This is maintenance that's performed after the tool has failed. The other type of maintenance is preventative maintenance. This is maintenance that the work's carried out in a pneumatic tool on scheduled intervals, so that way the tool is repaired before it's failed and it keeps it more productive. Third type of maintenance is no maintenance. This is going to be tools that you run, they fail, and throw them away, and then put a new tool in process. It's kind of similar to reactive maintenance, but there should be a distinction made. So this is a graph showing the performance of a tool when reactive maintenance is performed. So you get a new tool out of the box. It's running at 100% optimum performance, but this tends to decrease over time while the tool's being in use. You'll end up using it until the tool breaks down. You could be 50% of the actual performance of the tool. At this point, you would end up repairing it or throwing it away. Repairing it after it breaks, as Branko says, can lead to other damaged parts in the tool, such as a cylinder or gears in the tool, airlines, as opposed to the preventive maintenance, which we'll discuss next. So what is preventative maintenance? It's a program of regularly scheduled service on the pneumatic tooling. It helps to maximize the tool life and the tool performance. Again, it ensures that we're ensuring maximum investment when you're putting the type of money into a higher quality tooling. So here is that same graph, but on preventative maintenance. As you can see, we run the tool, or a new tool has 100% efficiency, it's operating. The tool's performance tends to decline then we'll perform a preventative maintenance. This is usually replacement of the vanes and the bearings. And you see how we can repeat this process over time. This will extend the tool life out. It's also minimize any variance in air tool repair costs, because you are only replacing, the common wear parts and not other parts that are in the tool. Maybe go to the next slide.
All right. So the theory behind repairing of our tools is every tool that we send out is made up of all the different parts, and we provide the exploded view diagram with each tool that we ship out. As you'll see, every single part has a part number and that can be ordered separately. So this is kind of a difference between your industrial grade air tools like ours and a cheaper air tool that does not essentially sell parts individually or is not meant to be repaired. So with on the diagram, you'll see some of the items that are highlighted in blue. Everything that's highlighted in blue, it would be part of a service kit that can be ordered separately. So what we want to make sure we do is, like Rhys mentioned, proactive maintenance. Order the service kits and repair them as needed, and not wait till the tool fails, because when the tool fails, the cost of repair is just going to go much higher. And if we continue to do that, your tools will last for a long time. I have a customer that had a tool for 10 years and has used it throughout with proper services and hasn't had any issues. Now, yes, the industrial grade tools are more expensive than the throwaway tools that we can buy at Home Depot or at a Harbor Freight. But over the life of the tool, if you're using the tools and you're throwing them out every 3 months and you're continuing to buy new ones, a service kit is a much lower cost than a lower grade air tool. So that's something to keep in mind. It's the big picture that we're looking to provide cost savings on. One more thing that I want to discuss while I'm on this slide is the service intervals. This is another very common question that we get asked. It's very difficult to give a customer or an operator a service interval that the tool should be serviced at, because every plant is different. Some plants might run tools 1 shift, some run them 3 shifts, 24/7. Some shops might run a tool once a week for an hour. So it's very difficult to gauge that. But what we always recommend with customers is start at 6 months. Service the tool at 6 months, send it back to us, or whether you're sending it back to us or servicing it in-house. We'll take the tool apart, look at all the parts, see what the wear is like. If the tool has some life left, we will suggest that we can bump that service interval to 7 or 8 months and go on from there. Or if the tool looks like it's well beyond its life, we will recommend a lower service interval, like 3 or 4 months. So just to kind of recap everything, preventative maintenance is key. If the customer or shop owner is buying expensive tools, for them to realize cost savings, they will need to take care of the tools, and they will need to do proper service at correct intervals. Otherwise, it's not going to be any different than throwing them away. So scheduled maintenance programs, obviously, like I said, to change out the bearings, vanes, and O-rings, the wearable parts. Avoiding breakdowns is going to be key. Managing tool population, safely maintaining tools, and more consistent costs. That's going to lead to. So managing tool populations, there is software out there that will allow you to manage your tool population. So let's say you're set on 6-month intervals, just like your metrology equipment, you can manage your air tool population in a similar manner, where your quality inspector will get a notice where it's been 6 months for this tool that needs to be repaired. Every one of our tools has a serial number on it, so it's easier to track. What we've done with a few customers also is, if by doing it manually. If you don't have the software to do it, you can do it manually. We put a tape on that's 6 months ahead of us. So when the operator is using the tool and that month comes up, they just return the tool, get a new one, and that tool goes out for repair. Troubleshooting a vibration is the next. So we're going to go over some major or some problems that are commonly seen with air tools, and then we'll discuss a little bit of vibration and how that has to play with when it comes to air tools. Vibration obviously can cause a lot of problems, and here's a few reasons why. Over and under speeding. If every tool comes out with a certain RPM range or RPM that it's supposed to be running at, and if we are running the tool, let's say 120 psi instead of 90, that tool is going to be running faster, which is going to be damaging the tool. Running 120 psi is going to also lead to a lot of vibration, which is going to damage the bearings and cause problems down the road. A worn motor is also going to be an issue, like we've mentioned a couple of times throughout this presentation. Overuse of the tool is not ideal, so servicing it before it gets to be too late is going to be critical in keeping the cost down. Damaged spindle. Seen this one a couple of times. You know, it could be a brand new tool, and out of the box it gets dropped on the ground, and it gets dropped right on the spindle. It could damage the spindle, which is going to cause higher run out and not have the tool run properly. So this is even more prevalent. The spindles are even more sensitive with the tools that are higher RPM because they have even tighter tolerances on the run out. Worn collet is very similar to the spindle, but overuse of the collet could cause slipping of the consumable. So the shank is going to slip inside the collet, which is going to cause vibration and all kinds of problems. So damaged consumables, similar to the collet, it all has to do with the run out. The lower the run out, the more accurate the tool will run and the longer it will run. Same goes with home attachments. Incorrect tool or consumable match. This is a big one. We need to make sure that we match the consumable with the appropriate air tool to run at the appropriate speed. So we need to make sure those three things are intact. I've seen this happen in the past. If we have a consumable that is rated for 30,000 RPM and someone's trying to run it in a pencil grinder at 75,000 RPM, obviously it's not meant to run at that RPM or at that speed. So first of all, it's a safety issue. Second of all, it's going to be damaging the tool. With excessive speed, it's going to come with the excessive vibration will be a part of it, which is going to be damaging, once again, the bearings and the rest of the tool. Vibration from a workpiece, it could be a problem. When we're working on deburring, we need to make sure that the workpieces are stable. Any kind of vibration that could be created by the workpiece needs to be eliminated for obvious reasons. And then air supply, quality, and quantity, we've already covered that one. So we'll talk a little bit about vibration and reducing it through reducing it by design. Our tools are made, most of the components are made on a CNC machine, so they're very high. We keep very high tolerances, which allows the tool to be very precise. So with precision, we're controlling the run out, and this is going to help out with tool life. So on top of that, our tool fitters or the folks that build our tools are very experienced, and they have consistently manufactured tools to the same spec. So going back to kind of the servicing of the tools, we offer servicing. AT as an organization offers repair of our tools that we sell. If you decided to do it in-house, we do have the ability to provide documentation of the tolerances, on the speed of the tool and the tolerances of that speed, and how everything is supposed to be taken apart and put together. If you are going to take our tool apart, please reach out to one of our salesmen or customer service for this information, because not doing it in the correct manner could damage the tool and make it useless. So that's very important. The trained tool fitters that build our tools, it's a big reason for our success with air tools. And then reducing vibration through the second step would be through our design. So some of our air tools you'll see have the anti-vibration noted on the spec. There's a few different types. It's mainly the larger tools. In the right angle grinders and sanders, we have what we call a spindle auto balancer. So essentially it's a spindle with 6 bearings inside of it that relocate themselves to an imbalanced spot of the consumable and balance the tool out. And then we also have the anti-vibration side handle, which is a thick rubber coated handle instead of that has a little bit of play, so it dampens the vibration instead of a solid ceramic handle. Not only is vibration harmful to the tool and will reduce tool life and increase your production cost, it's also harmful to the operator that is using the tool. There's a lot of information on this. If you or your customers are having issues with safety, please let us know, and we can inform you about this and help you improve your process. That way you're avoiding these risks. But this is called HAVS, or hands-arm vibration syndrome. It happens when an operator is exposed through a high level or a high magnitude of vibration throughout a period of time. And essentially, what happens is the wrist starts to swell up. It's kind of like carpal tunnel. The wrist starts to swell up, which restricts the blood flow to the hand and the fingertips. With the lack of blood flow, the small capillaries in the fingertips start to die out, and the fingers start to turn white, as shown in the first picture above. This is obviously a big problem. It's a disabling disease, and once the damage is done, it is permanent. It can't be reversed. So essentially, it's very similar to frostbite. Fingers turn white, and then in extreme cases, fingers start to turn black and would need to be amputated. So something to be mindful of now. Not all air tools create the higher vibration or vibration of this magnitude that can cause the problems. For that reason, that's why we have die grinders that are 0.8 horsepower or 1 horsepower and up have the features, as well as angle grinders and sanders are at 1.5 horsepower and up. So it's going to be with the higher horsepower tools. And then I have 2 quick videos that will show you what a low vibration tool versus a standard tool looks like. This one is on a die grinder. And I'm going to fast forward here where you can see. So this is a low vibration tool that we make. It's a 30,000 RPM grinder. You can see the steadiness, and it's not jumping around, while on the left side you can see the feedback that the vibration is giving. So this feedback is not only damaging to the air tool, it's also damaging the consumable. So it's going to just cause much more problems and leave a worse finish and increase your production costs with consumables and air tools. The next slide is a video of right angle sanders. So we demonstrated this at IMTS in 2016. What we have here is on the left side is going to be a standard angle grinder with a ceramic handle without the spindle auto balancer. All we did is attach the water bottle at the end to show you the vibration that the tool or the operator experiences. On the right-hand side is a tool with the auto balancer with the anti-vibration handle. So here's the video of that. I know these videos might not be the best through a webinar, but if you guys do want to see these, we can get them sent out. One of them is on our YouTube channel, and the second one right here we can add to our YouTube channel as well. So that is all that we have for today. We're going to go ahead and answer some questions that we got through the chat. And then if anybody has any questions, feel free to either raise your hand or unmute yourself and go ahead and ask at this point. So first question we have is, where does the oil go that does not make it to the tool? So once the oil goes through the tool, lubricate the cylinder, it comes right out of the exhaust. So if we, the one thing like I mentioned earlier, if we start to see an excessive dripping of oil through the exhaust, then there's too much oil going through it, and we should turn down the drip rate. And then let's see, another question from Matt here. Are there any test units in the field that customers try to compare to what they're using now? Yes, certainly. We have so we have reps throughout the whole U.S. Covering the territory. They should have a air tool sample kit, and also any all our regional sales managers are going to have sample kits as well. If an air tool that you're looking to test is not in a sample kit, we can certainly provide a tool to test. We'll just need to know what you're looking for. And typically with air tools, what we do is we provide them under a GTO. So an order is placed, we ship out a brand new air tool. We have 30 days to test it. Once that 30 days is up, if the customer decides to keep the tool, then nothing happens. We proceed with the invoice, and that's that. If they don't like the tool, we take the tool at without any restock fee. We just take the tool back and issue a credit for the PO that you provided. Any other questions? If you do have them, like I said, just go ahead to the top of your screen and hit unmute and ask it. Rhys and I will be more than happy to answer them.
I've got a quick question, Branko.
Yeah.
This is Glenn with Kenville Engineering.
How's it going, Glenn?
Hey, I'm doing good. On this presentation, you showed an application of a large grinding part that had an oiler filter, you know, basically on a fixture that was on the floor. All the applications looked proper to me, except it looked to me like that oiler filter would benefit from being up on a cart and elevated. Is that a safe statement, or would it really matter?
It would, but the reason I included that in this presentation is it's better to have a lubricator unit than not to have one. So for the most part, especially in that environment, you will not see a lubricator unit. But yeah, on a cart, not only is it going to be above the grinding area, it's also going to be easier to move around.
I agree.
I'd rather be pushing a cart than carrying that thing. So.
Yeah, from a safety standpoint, less of a trip hazard also. But yeah, that was a good slide. And I've got one more quick question. You mentioned that a vane escaping can definitely increase the repair cost. Can an escaping vane, you know, one that's wore out and escapes, can it actually scrap the air tool?
So because every one of our, like I showed you the diagram with all the exploded view diagram of the air tool, any of the parts that are used to build up this air tool can be bought separately from us. So essentially, you can buy all the parts and build your own tool if you wish. So nothing will scrap the whole tool. So the tool really, you can, once you buy a tool, you can be replacing parts forever if you wish.
I've got you. So even housing that could get gouged is replaceable.
Correct. Now, so this happens once that vane escapes and it lodges itself in there. What happens is it scars that internal wall of that cylinder, which obviously you can't run a tool with that because you're risking breaking new vanes once you do repair it if you don't replace that part. Now that part is CNC machined, so a machine part is going to be a lot more expensive than, let's say, a bearing. So this drives the price of repair up. So this is why we want to avoid running the tool until it completely seizes up and service it beforehand, because it's going to yield to saving us money.
Perfect. So again, I appreciate the presentation. This was great.
Okay. Got another question that came through the chat. It says, do you have a PDF download catalog for the tool line. The online catalog doesn't always work in plants where reception can be challenging. Yes, so our website, our new website, which we launched a few days ago, you can actually go under the Air Tools and click on the catalog and download. Once you open the catalog, you can click on the download button and it will download it actually to your laptop or iPhone or tablet or whatever you're using. So that's one way. Another way is if you reach out to one of the regional sales managers or your reps, we can send you a PDF version of the catalog. Does anybody have any other questions? Going once. All right. Once again, Rhys and I would both like to thank all of you guys for participating. If you have any questions, please reach out to one of us. We will be sending out a thank you email, and it's going to have our contact information in it. Like I said, if any questions come up after this, or you think of something, please do reach out to us, and we will get that answer for you. Other than that, thank you guys again for showing up, and stay safe and have a good day.
Thank you. Appreciate it.
Great job. Thank you, gentlemen.
Thank you.
Thank you.